G'day. In this episode I'm going to talk about these little voice recording modules. I bought these back in 2000 from an Australian company called APlus Electronics, and I know that because for some reason I've still kept the receipt from way back then. So what I've got here is a 30-second, just a single recording module. Let's have a little close-up look at those. Now these chips, all three of them, are based on a company called APlus. And this particular small one here is an APR9600. It's a little encapsulated chip under that glob of black goo. A couple of push buttons, an LED and an electrolyte microphone there. This one here is based on the APR9600 chip from the same company, APlus Integrated Circuits. This particular board was designed to go into a little jiffy box, and there was some switches to connect on these pins here. This one also has a little audio amplifier, an LM386 with a volume pot, and once again a small microphone. This one is also based on the APR9600 chip. In this case we have 8 little push buttons, one for each of the messages that's capable of in a particular mode. You can have it in various modes, but it's also got a play and a record latched push button there. Not entirely sure what that one was for. We'll work that out as we go along. And in this case there's no audio amplifier on board, but supposedly these chips are actually complete with a built-in amplifier capable of driving a small speaker. Okay, so we'll start off with this little 30-second voice recorder board module. Let's connect it up and see if it works. I've got a little battery carrier there. There's a couple of pins for the supply. Just a small 8 ohm speaker to hook in. And we'll give him some power with a little switch on the battery pack. with this one, I've got absolutely no response at all. There's nothing lighting up on the play record LED. When I press the play button or the record button, no sound coming out of the speaker whatsoever, which leads me to think that this board is kaput. Alright, let's move on to the next one. This board here, as I said, was designed to go into a little jiffy box, or a little hobby kit box. The only paperwork I've got, which is not really paperwork, is this cockroach-eaten sticker, which was designed to go over the hobby jiffy box. And you can see that there's a little bit where you can cut holes in for a speaker grill. There's a couple of spots there for the LEDs indications, a play record switch, and there is 4 push button places for switches on that. So this particular chip is set up in a mode where it only takes 4 push buttons. So let's have a little look and see if this one works. Once again, I don't have any information on it, so I'm not entirely sure how the power hooks up to it, but this one's clearly marked speaker down here. There's a couple of pins here that are marked PWR for power, but it doesn't tell me which is the positive and which is the negative. This one's marked B, there's one over here marked A, and there's 3 pins here, and it says link for 6 volts. I'm not entirely sure what that means. There's no lights on or anything, and I'd probably need to jumper some of these other jumpers, the play record, and for the message playback I would need to jumper some of these pins for each of the 4 messages that you want played back or recorded to. So at first glance, this particular board doesn't really do much for me at the moment, but we'll revisit that in a minute. The third board here is we may have a little bit more luck with. Once again, I've got my speaker pins down here. And we've got a power supply connection down here. Turn him on. Hopefully you can hear that all right. That's in the play mode, and I've actually played around with this off camera before to see if it works, and did a couple of recordings. So that's a good sign. This one is actually working. And now this has a mode where you can turn it into record mode. And pressing and holding one of these buttons will record a message on each of the 8 different inputs. Testing, 1, 2, 3. And then we switch it back into play mode, and we should be able to get that message through.
Testing, 1, 2, 3.
And now if you can hear that, or if you'll notice it's very low volume, so I suspect there's some problem with that microphone. The fact that the beep sound is reasonably loud would suggest that the chip is certainly capable of driving those small speakers like that. What else? Let's just try recording on some of these other push buttons. This is message 1. This is message 2. This is message 3. This is message 4. This is message 5. Message 6. Number 8. Actually, that was number 7. What am I saying? No, this one is number 8. All right, we'll go back into play mode, and we'll see what came out of that.
Message 1. Message 2. This is message 3. This is message 4. This is message 5. Message 6. Number 8. No, this one is number 8.
All right, so that's good. That is a working board. So what we might do is we can remove the chip off this board and stick it on this board, and that will just give me an indication whether this this chip here is okay or not. I'm trying to prise the chip out very, very carefully because it is quite old, and I suspect the little bit of oxidization on the pins that will hold it in place. All right, great success. And it's good to get under there because there's a few other components that are hidden underneath this IC socket. So I'll be able to work out a little bit more about that board and what's wrong with it once the chip's out. So now we'll get this other chip out. Again, being very, very careful just to get that started. Okay. Alright, we can go ahead and hook the power back up. And the speaker. Testing, testing. Testing 1, testing 2, testing 3, excuse me, number 4, number 5, excuse me, I got a frog in the throat. Where were we up to? Number 6, number 7, and number 8. All right, great success. It looks like both of those chips are working. So let's have a look at the data sheet for this particular chipset. once again we've got our pin out for the dual inline pin dip package. And we've got a nice little functional block diagram of how it works. So we have flash EEPROM storage here, a nice non-volatile memory. In fact, when I first powered this on off camera, I was able to get it to work, and there was in fact a recording there that I'd made back in 2000. So this board hasn't been powered up for 20 years and it still retains its memory. You can see the built-in amplifier for the speakers, for the speaker. It's also got a microphone input preamplifier with an automatic gain control. Yeah, you can also put a line in. There's an internal oscillator here which is set by a resistor, and what that does is you can set up your the sampling frequency depending on the value of the resistor. So we can sample at 8 kilohertz is the best quality, but then that affects the duration of the total time that you can record. So it's down to 32 seconds from 60 seconds is the lowest quality sound that you can record. There's a few other pins as well, so which is going to prove pretty handy. The microprocessor controlled message management, and so there's a busy pin, a strobe, and a end pin, but also the chip enable pin, which is going to be useful for what I have in mind for this particular playing around with. So the rest of the document has some sample applications, very nicely laid out, and some more information on each of the pins. And then more of the specifications. The power supply voltage, minimum of 4.5, typical 6, and maximum of 6.5. So it's designed for 6 volts, but I'm hoping I might be able to run it off 5 volts so that it's more in line with the most power supplies nowadays for microcontrollers. A couple more circuits down the bottom here, and one in particular I'll be interested in is using the line in instead of the microphone, because obviously the quality of the sound samples is a little bit iffy with the electrolet, the typical electrolet microphone. These chips were really designed for, by the looks, using in as a digital replacement for telephone tape messages. So there's a whole bunch of functions in here for playing back in tape mode, so it simulates a tape telephone message machine. So auto rewind options and all that sort of stuff that I'm not particularly interested in for what I have in mind. It also has several different modes to do with that, and there's a couple of pins that you can set to set those modes. So you can have 2 messages, 4 messages, or 8 messages, or there's a tape mode, normal operation, tape mode, auto rewind operation. If you remember that other board here, it only had the 4 push button inputs, so that one was set up for the 4 message durations. So there you have it. There's something that we might experiment further with. What I might do now is take one of these chips and put it on a breadboard using the sample circuit diagram, and yeah, experiment around on a breadboard. Okay, we're back again. Off camera, I've got to do a little bit of troubleshooting to get it to work. I've only connected 4 push buttons to because of that's the I've only got 4 push buttons available to me. In which case I've put it into the 4 message mode by only having one of the jumpers here on those pins that select the mode. And in that mode I've also had to add a 100k resistor to pull the message 8 pin high. So let's do a little recording and see what happens. Recording message 1. Recording message 2. Recording message 3. Recording message 4. And I haven't got a slide switch to change the mode from play to record, so I'll just move this jumper here to take it high. I'm not sure if you could hear that, but it did record all 4 messages. There's a little bit of popping sound on the All right, so that is the APR9600 voice recording chip. You know, another episode, what I'm going to do is add an amplifier to get it a little bit more volume out of it. We might try and play around with using the line in function and recording directly off a line source. And I'm also going to play around with interfacing it with an Arduino microcontroller, and yeah, experiment a little bit more and have some fun. All right, we'll catch you on the next episode. Cheerio.